All right, problem 5 from the free response section of AP Calculus AB 2024. So here we got this curve, this fancy equation. This is going to be an ellipse. You don't actually need to know that, but I just thought I'd point that out, which is going to be like a stretched out oval, like circle-ish. And it can be shown that this is the derivative for this, this curve. And you can see right away we're going to be dealing with implicit differentiation. So make sure you remember that when you got x's and y's in the derivative equation, that you're going to be doing like implicit differentiation. So let's just get to part A now. There's a point on the curve near 2, 4 with x coordinate 3. So use the line tangent to the curve at 2, 4 to approximate the y coordinate at this point. Okay, so we're basically just going to find the equation of a line, of a linear equation, and we're going to use the fact that we have its derivative that we can calculate. So again, we're finding an equation of like y equals mx plus b. The m is going to be the derivative when you plug in 2, 4. So we plug 2, 4 into here. We'll get negative 4 over 19. Okay, so m is negative 4 over 19. So far then we have y equals negative 4/19 x plus b. We can find the y-intercept b by just then again plugging in 2, 4 for x and y into this equation, solving for b. So I'm gonna cram it in here, even though I don't like doing it, just so I make use of this space. Don't really have a good reason, but okay, 4 equals negative 8 over 19 plus b. Solving for b, this will become 2856. So then 56 plus 8, 60, no, 84. Yeah, because this is gonna be 76, my bad. So b is 84 over 19. Now this is gonna be a tedious one, as we can see. That's what makes it fun, I guess. So our equation will be this. And now we just use this to find the y coordinate by plugging 3 into here. So we're gonna get another weird ass like number. Yeah, so I'm gonna do it over here. I promise the rest will be nice and organized, but I just gotta keep up with this chaos. So plugging in the x there, we will get y equals negative 12/19 plus 84/19. How many 19ths will we get? 72/19. Yeah, 72/19, and that's your answer for y. Yeah, so I could definitely imagine if you're a student and this is like the first part of this problem, you're probably gonna be thinking like, oh, I'm doing this wrong. Yeah, I'm kind of hoping I'm not doing it wrong, but yeah. So just know that stuff like that will happen. But it doesn't. But since you already took the exam, I hope that you guys powered through this and didn't get thrown off by this. Anyways, that's sorry for sidetracking there, but that's our y value. Now part B is the horizontal line y equals 1 tangent to the curve. And why? Give a reason for your answer. So if the horizontal line, tells you it's horizontal, it's going to have a slope of a 0. Y equals 1. So the slope is 0 because it's horizontal. So that means that you would have to you could set this derivative equal to 0. And That's interesting. Well, I mean, there's like you can right away tell it's no, because if you were to plug in 1 into this equation, the only way you would need to get 0 for x for this to be. The only way this could be 0 is if x is 0. But that means if you plug in 1 for y to the equation, you should get 0 for x. But you can see right away that you're not, because you're going to get x squared plus 3 plus 3 times 1 plus 2 times 1 squared. So x squared plus 5 equals 48. And you're going to get x squared equals 43, or x squared root of 43. Another weird answer. So yeah, it's going to be no. And I mean, I guess the formula you would say it is because the derivative would then be equal to 0, because that's the slope of the horizontal line. And since you don't get 0, or since, you could just show, I would probably just show the work, plug in 1 into here, and then you're going to get the square root of 43 there. Plugging that into there is not going to be 0. This is a weird question, but yeah, I mean, again, don't overthink this one, because you want to get 0 for this equation. The only way you can get 0 for this equation is if you get 0 for x. All right, moving on. Part C. The curve intersects the positive x-axis at the point square root of 48. Okay. Square root of 48 comma 0. Is the line tangent to the curve at this point vertical? Is the line tangent to the curve at this point vertical? That sounds, I don't know if I'm reading that wrong, but okay, so it's basically saying is there going to be a vertical tangent line at this point? So you're going to have a derivative that's going to be like blowing up to infinity. So you could plug this in to here, and you just wouldn't get that. That's, I mean, really all you would. I guess that's all. I mean, you just have to basically show that and say that, because again, you're looking at this derivative. The derivative, when it's vertical, is going towards infinity. If you plug in square root of 48 for x, you're going to get -2 square root of 48 over 3 plus over 3. And this is not going to be infinity. Okay, and then in part D, oh, make sure you said no. I guess it's no. Maybe with an exclamation point, like show like you know what you're talking about. For time t is greater than or equal to 0, a particle is moving along another curve defined by the equation y cubed plus 2xy equals 24. The instant the particle is at the point 4, 2, the y coordinate of the particle's position is decreasing at a rate of 2 units per second. So if it's decreasing at a rate of 2 units per second, that means the change in y with respect to time is -2. So let's write this down here. The dy dt is -2. What is the rate of change of the x coordinate of the particle's position with respect to time? And this question, so yeah, this one, when I first read it, it kind of sounds weird, but you just have to differentiate this. And again, use implicit differentiation and differentiate with respect to t. Yeah, I'm sorry for my mumbling and jumbling. It's past my bedtime, but I'm gonna power through this. So that would just be, again, 3y squared times dy dt. This you're gonna use a product rule, so we're gonna get plus 2. The derivative of x is just 1 dx dt, y times y plus 2x. This time the y, we get dy dt times 1. We don't need to write the 1 again, but you would have this equal to the derivative of 24, which is 0. And then let's rearrange these. Let's factor out the dy dt's in front, so it looks all nice. So we get 3y squared plus 2x plus dx dt times 2y equals 0. Now we have the dy dt because it's telling us at this specific moment, the derivative is -2 units per second for the y. So then we replace this with -2. And then we know that the y is 2 and the x is 4. So let's just plug in those values correctly. So y is 2. So we get 3 times 4, 12. X is 4. So 2 times 4, 8. Then we're solving for the dx dt. So let's leave it as is. And 2 times 4, or 2 times 2 is 4, equals 0. So now it just becomes an algebra equation that where we're solving for dx dt. This becomes 20, -40, add the 40, and then divide by 4. So we get 40 over 4, and we get 10. Okay, at least that one worked out nicely. And that's all, folks. There you go. That's all there's to it. Okay, so I hope that helps. Again, leave me feedback if something I said or was confusing, or if I made a mistake. I don't think I did. I'm pretty confident in this one, but I never can be sure. And of course, you know, if this is helping you, make sure you give me if you want to give me a like and subscribe, and I'll see you guys in the next video.